implementation of AI error detection to enhance 3D printing quality and efficiency using real-time monitoring application. This is a requirements for the elective 6, and we are the group 1. I am Chleo Trinos, and my groupmates are Perez Erick Brian, Mararac Jhon Louie, Hernandez III Napoleon, Hatulan Reine, and Gonzales and Michelle. And for our table of contents, ayan, we will going to start sa background of the study, objectives, applications, up to the reference and plagiarism checker. And for our introduction, ayan, for our introduction, syempre, i-discuss natin dito yung 3D printing. 3D printing, also known as additive manufacturing, is a revolutionary technology that enables the creation of physical objects from digital models. It works by depositing layers of materials such as plastic, one of top of the other until the desired shape is achieved. However, the current 3D printing technology still faces some challenges, particularly in monitoring the real-time status of the printing process. Sa course nga namin, which is sa ECE, nagkaroon kami ng requirement which is to 3D print some objects na i-design namin using SolidWorks. So, gamit na gamit tong 3D printing, etong 3D printer namin dun sa aming mga requirements. And also, hindi lang yon. While ginagamit namin yung 3D printer, nagkakaroon talaga ng error and hindi may iwasan yung pagkakaroon ng error, lalo na dun sa mga filament. Ayan. And one of the major problems is the risk of failed prints and potential damage to the printer when left unattended. Unattended 3D printing can pose various risks such as fire hazard and mechanical failures. Ayun nga, due to the failure na sinasabi kanina, nagkakaroon kami ng sira sa mechanical since minsan yung mga filament na sumosobra pagka hindi agad namin na-stop yung processing na 3D printing, nagkakaroon siya ng problema dun sa motor na ginagamit ng 3D printer. Due to the complex and lengthy printing process. Ayun nga, sinabi ko kanina, dahil nga matagal yung printing process, hindi talaga may iwasan yung errors and damages dun sa printer. The printer can run out of filament or experience other mechanical issues, resulting in failed prints that may require restarting the process from scratch. Ayun nga, since nagkaka-error nga, hindi naman pwedeng i-continue lang natin yung process. Uulitin natin sa simula. So, maraming nasasayang na filament and marami ding nasasayang na oras. This can be costly and time-consuming problem, especially for large-scale manufacturing. In addition, it can be convenient for users to constantly monitor the printing progress, especially for long print jobs. So, with these errors, etong problema na nakita natin, paano nga ba natin ma-address yung issue na yon? To address this issue, several solutions have been proposed, including the use of webcam or monitoring software to provide real-time updates on the printing progress. However, this solution often requires manual intervention, which defeats the purpose of automating the 3D printing process. A more efficient and reliable solution is use of a mobile application to control the 3D printing process remotely. With an app-controlled 3D printing system, users can monitor and control the printing process from their smartphones or tablets. They can check the real-time status of print, pause, or stop the process and receive notifications when the print is completed or when an error occurred. Ayun nga, to address nga yung issue, nag-integrate kami ng application, ng mobile application dun sa system ng ating 3D printer para ma-check natin. Kahit nasan tayo, yung 3D, yung piniprint natin sa bahay natin using the 3D printer can be monitored real time. Ayan. Pag may nakitang error dun sa piniprint natin, magkakaroon siya ng notification dun sa ating mobile phone, which is, meron dun, makikita din natin dun na pwede natin i-stop or pause yung process na ginagawa para hindi na tayo bumalik pa sa umpisa and hindi siya mag-cause ng time and ng filament na ginamit doon sa 3D printer. The proposed project builds on an existing literature on 3D printing and AI technology. According to the study, 3D printing technology has been widely adopted due to its ability to produce complex designs and prototypes quickly. However, the process of 3D printing can be prone to errors, such as warping and cracking, which can result in wasted material and time. Ayun na, kagaya ng sinabi natin kanina, doon nga sa error na nangyayari, which is warping and cracking. Ayan, pinropose tong project na to para maiwasan natin yung pagkasayang ng filament or ng material na ginamit and yung time ng pagpiprint. Moreover, AI technology has been increasingly applied to manufacturing processes to detect and prevent errors. For example, an AI-based system for error detection in additive manufacturing, which used machine learning algorithm to analyze 3D printing data and identify potential errors. Ayun nga, dun nga sa ginamit nating algorithm or sa system, embedded na din yung error detection na pagka may nakitang error dun sa pagpiprint, automatic na siya na mag-stop or automatic na may magsesend ng notification doon sa ating mobile app. The proposed project aims to develop an app-controlled 3D printer that integrates real-time monitoring and AI printing error detection. The app will allow users to remotely control the 3D printer and monitor the printing process in real time. Ayun nga, kagaya ng sinabi ko kanina, kahit nasan tayo, ma-check natin and mamomonitor natin yung piniprint natin real time. Additionally, the AI system will be integrated to detect and prevent potential errors, such as warping and cracking. The 3D printer will be equipped with sensors to collect data on the printing process, such as temperature, humidity, and printing. Ayun, hindi lang natin makikita sa mobile app yung real-time na nangyayari sa printer natin, hindi lang natin siya ma-stop or pause, but also makikita din natin doon yung temperature, humidity, and yung printing speed ng ating piniprint. This data will be transmitted to the AI system for the analysis. And the system will use machine learning algorithm to detect potential error to provide real-time feedback to the user. Again, the proposed project is expected to result in the development of an application-controlled 3D printer with real-time monitoring and AI printing, error detection. The integration of AI technology is expected to reduce error and waste during the printing process, resulting in increasingly efficient and cost-effective na process. Ayun, uulitin ko, itong project na to is to reduce error and waste, lalo na dun sa filament since medyo mahal nga siya, para magkaroon tayo ng mas efficient na pagpiprint and mas cost-effective. That is for the introduction and next objectives.
So for this part, these are the proposed project aims to achieve the following objectives. First is to develop an app-controlled 3D printer that allows users to remotely control. So for this part, the proposed project aims to achieve the following objectives. First is to develop an app-controlled 3D printer that allows users to remotely control the printing process and monitor it in real time. So for this first objective, it aims to create a user-friendly interface, most likely in a web-based browser that enable users to control and monitor the 3D printing process for anywhere. By utilizing this application, the user can start, pause, or even stop the printing process remotely, and as well as receive real-time updates on the progress and status of their prints. So this feature enhances convenience and flexibility for users, enabling them to manage their printing process more efficiently. So for the second objectives, to integrate an AI system into the 3D printer to detect and prevent potential printing errors such as warping and cracking during the printing process. So for this second objective naman, by incorporating an AI system into the 3D printing, the technology aims to enhance the reliability and accuracy of the printing process. So for the AI system can analyze various factors during the printing process, including the temperature, the filament flow, and even the printing speed to identify potential issues that may lead to potential errors or printing errors during the printing process. And it can then take proactive measures to mitigate these failures, such as adjusting the printing parameters or notifying the user to intervene. So the integration also helps improve the quality and success rate of the 3D printing while minimizing the chances of mistakes or failures. So for the third objective, to equip the 3D printer with sensors to collect data on the printing process, such as temperature, humidity, and printing speed for analysis by the AI system. So to enable the AI system to make informed decisions, the 3D printer needs to gather relevant data during the printing process. Sensors can be incorporated into the 3D printer to collect data on various parameters such as temperature, humidity, and printing speed. This data provides valuable insights into the conditions under which the printing is taking place. The AI system can then analyze this data in real time to make adjustments or provide recommendations to optimize the printing process and ensure outcome and successful outcomes. So for the last objective of this proposed project, to contribute to the advancement of 3D printing technology by integrating AI technology into the printing process. So for this last objective of integrating AI technology into the 3D printing process is to push the boundaries of what is currently available or achievable in the field of 3D printing. By leveraging the capabilities of AI, the project aims to enhance the overall efficiency, accuracy, and reliability of the printing process. The integration of AI technology can lead to new innovations and techniques that improve the quality of 3D prints, reduce material waste, and minimize the need for human intervention. Ultimately, this integration contributes to the advancements and evolution of 3D printing technology as a whole. So by achieving these objectives, the proposed project aims to enhance the capabilities of 3D printing technology by integrating AI technology and real-time monitoring. This integration is expected to reduce errors, waste, and potential risks, thus improving the overall quality and efficiency of the 3D printing process.
So for the next one, we will move on to the application of this proposed project. First is the defect detection. By analyzing the printed layers and comparing them to the desired design, AI algorithms can detect defects, irregularities, or missing features. This allows for early detection of errors and enables prompt corrective actions. Next one is the print quality assessment. By analyzing factors that contribute to the overall print quality, AI can identify deviations from the expected standards. This helps in ensuring that the final printed products meet the desired specifications. The third and the last one will be the failure prediction and prevention. AI can be utilized to predict potential failures in the 3D printing process by analyzing real-time sensor data from the printer, such as temperature, pressure, or speed. AI algorithms can identify patterns or anomalies that can indicate a potential failure. This allows for proactive maintenance or intervention to prevent printing errors and reduce material and time wastage.
So now proceeding to the scope of our project. So this project will concentrate on the development of the app-controlled 3D printer with real-time monitoring and AI printing error detection. So as mentioned earlier, our primary objective in this study is to ensure that the system is capable of identifying errors and preventing it to save materials and time during the printing process. Um, some printing errors that it can detect are warping and cracking. Uh, Next slide. We will discuss the limitations of our project. So, while we strive to enhance the 3D printing process, there are still certain factors that fall beyond on the scope of our project. So, we will not be addressing other factors that may impact the printing process, such as the quality of the input design or the printer's hardware. Our focus primarily is on the error detection and prevention aspect. Now, continuing to the main frame of our project, it consists of the input, process, and output stages. The input stage involves the hardware components, including our 3D printer itself, including the sensors and actuators attached to it, a webcam to monitor the status of the printing process, and the Raspberry Pi as the microcontroller for the hardware control. So additionally, we also have integrated AI algorithms into the system to enable error detection and analysis. Moving on to the process stage, we have implemented data acquisition system. The sensors on the 3D printer will continuously collect relevant data such as temperature, filament usage, and other parameters which will be reflected on the GUI that we have created. So, next slide. Upon error detection, our real-time monitoring application comes into play. It provides immediate feedback to the user, generating alerts or notifications, informing them about the detected errors and anomalies. Finally, we will discuss the output of the project. So this real-time monitoring application not only generates error alerts or notifications, but also provide actionable insights. These insights include specific recommendations for addressing detected errors, assisting the user in making adjustments immediately. Ultimately, the implementation of AI error detection and real-time monitoring aims to enhance the overall quality and efficiency of 3D printing.
Yan. Let us proceed now to the schematic diagram. Now dito, included yung data flow, the hardware, and software components. So let us further discuss that information. As you can see, we have this user interface, the mobile application, or even the laptop. Then the microcontroller, which is the Raspberry Pi 3, the hardware components, which is the 3D printer. Now, the data flow is a crucial aspect for implementation of our 3D printer monitoring. Sensors integrated into the 3D printer continuously collect data on parameters such as temperatures, humidity, printing speed, and even the amount of filament that has been used. Furthermore, the sensors, the microcontroller interfaces with the sensors collects the data and pre-processes it for further analysis. The pre-processed sensor data is transmitted to the AI error detection system, and this system applies machine learning algorithms to analyze the sensor data, detect potential errors such as warping and cracking, and also provide real-time feedback monitoring. Now, this monitoring application receives the feedback from the AI system and displays it to the user through a user-friendly interface, which is the mobile application. And also, users can interact with the application to control the printing process, monitor the progress, and receive notification on the print completion or when errors occur. Now, next slide. So, here lang po yung data flow process na nabanggit lang din po kanina. Next slide. Next slide. So let's take a look at the hardware components involved in our 3D implementation. So we have this 3D printer, the physical printer used for additive manufacturing, the microcontroller, which is a Raspberry Pi 3, that interfaces with the sensors, collects the data, and transmit it for analysis. And these hardware components work together to ensure accurate data collection and transmission. Now, let us proceed to the software components that form the backbone of our implementation. First is yung real-time monitoring application, a mobile application that allows users to remotely control and monitor the 3D printing process in real time. It also provides user interface for controlling prints, setting, and receiving real-time status updates. AI error detection system. It is an AI-based system integrated with a 3D printer and and the monitoring application. It utilizes machine learning algorithms to analyze the collected sensor data and detect potential errors during the printing process, such as warping and cracking. So the communication protocol is enables seamless data transmission between the sensor, microcontroller, and the monitoring application, which is yung user interface mobile application. Now, here we have proposed implementation offers several benefits and impacts on 3D printing quality and efficiency, which is enhanced quality, real-time monitoring, user-friendly experience, and time and cost savings. Now, this significant advantage improve the printing quality and efficiency by leveraging sensor data, machine learning algorithms, and user-friendly interfaces. We empower users to achieve better printing outcomes while minimizing errors and maximizing productivity.
Now let's talk about the construction and development of our project.
Walang ka.
Research and planning. Conduct a thorough literature review to understand existing research, technologies, and best practices related to 3D printing, AI error detection, and real-time monitoring. This includes studying academic papers, industry reports, and patents. Identify the specific requirements, objectives, and the scope of the project. Determine the desired functionalities, target user base, and the potential application for the app controlled 3D printer system. Consult with the expert in the field, including 3D printing professionals, AI specialists, and software developers to gather insights and refine the project's plan. Create a detailed project plan with the timelines, milestone, and resource allocation to guide the construction and development process. For the hardware setup, select a suitable 3D printer model based on the project requirements, such as print volume, resolution, and the compatibility with the desired sensor and microcontroller. Acquire the necessary hardware components such as the microcontroller, camera, and the communication cable. Follow the manufacturer's instructions to assemble and calibrate the 3D printer, ensuring it is in the optimal working condition. Connect and integrate the camera and the communication cable with the microcontroller, and considering factors such as camera placement, wiring, and compatibility with the chosen microcontroller. For the software development, determine the programming language and develop the framework for the real-time monitoring application based on the target platform. For example, iOS or Android. Develop the user Develop the user interface for the monitoring application, focusing on providing intuitive controls, real-time real-time progress updates, and notifications. Implement the necessary communication protocols such as Wi-Fi or Bluetooth to enable seamless data exchange between the monitoring application and the microcontroller or sensors. Develop the AI error detection system using the appropriate machine learning algorithms such as convolutional neural networks or recurrent neural networks. Train the AI models using the relevant datasets, either the publicly available or custom created, to recognize the different printing errors accurately. This involves preprocessing the data, splitting into training and validation sets, and fine-tuning the model parameters. Validate the validate the trained models using the evaluation metrics such as accuracy, precision, recall, and F1 score to ensure their effectiveness in detecting and classifying printing errors. And integration and testing integrate the developed software components with the hardware setup, ensuring the proper connectivity and data transmission between the monitoring application and microcontroller and sensors. Conduct a comprehensive testing to validate the overall functionality, reliability, and performance of the app control 3D printer system. Test the system under the different scenarios and conditions, including varying print materials, environmental factors, and printing settings. Evaluate the real-time monitoring application's responsiveness, user-friendliness, and effectiveness in providing accurate progress updates and notifications. Assess the AI error detection system performance by simulating various printing errors and measuring its ability to detect and classify them correctly. Identify the address any bug and address any bugs, software glitches, or hardware issues encountered during the testing phase. Deployment and evaluation. Deploy the fully functional controlled 3D printer system in a suitable environment such as manufacturing facility, design studio, or research laboratory. Monitor the system's performance over an extended period, collecting data on error detection rates, printing quality improvements, and overall efficiency gains. Gather feedback from users, including operators, designers, or researchers, to assess the system's usability, reliability, and the potential areas for improvement. Analyze the collected data and user feedback to evaluate the effectiveness of the implemented solution, comparing it against the initial project goals and expectations.
For the materials used, we have used the Raspberry Pi 3 model, and second, the webcam and USB cords, and lastly, the 5 volts 6 amp power supply adapter. For the tools equipment, we have used the model of Engr 3V2 3D printer. For the costing, we have list the prices of each item, and overall, our it it will be 16,259 pesos. Here are the references used in these studies. And for the plagiarism result, we can see that it is the paper we have made is 100% unique.
So now let's watch a short video about this project.
Again, this is implementation of AI error detection to enhance 3D printing quality and efficiency using real-time monitoring application.
We hope that you learned something new today. That's all, and thank you.